Plenty of empty seats still.
We adopted the forward task class, lifetime guidelines, draft IETF, and SMA. These are the concepts being worked by the working group chair, and then there will be the ISP. We have a whole bunch of working groups adopt the drafts. You can read these on the front here, just regarding LS distribution, RTC, route oscillation, close tech, and more about service. Does everyone hear me? Is it any worse here? No. It's not on?
Really?
Yeah, well, that's right. You don't need to talk to people. Well, that's going to be hard to do. Well, I'll just sit down and talk. Okay, it's just the next people won't have as much fun.
You'll be talking out of the box.
Yeah, I'm talking out of the box instead of thinking. Okay, I will, 6 double A's. Okay. Is it working now? Okay. Okay, in the work for May, we're looking at April and May holding some more interims. I usually am trying to, for those people that are standing in the back, come in, find an empty seat. There will be no empty seats, so sit down next to someone, ask them to move their backpack. Don't be shy today.
There's an empty seat next to you. Can you please hold up your hand?
Okay. Again, if you have an empty seat, will you please hold up the hand so we can get everybody in? I have an empty seat up front here, Waymo. G, there's a couple more empty seats over here. Okay, we are going to go back into our process of working on targeted things each month. We will be looking at a couple drafts that are implementation drafts to push them forward. The LS distribution implementation draft may need another revision. The AdPath implementation draft needs to go forward, and the AS migration draft, which Wes will be talking about shortly, and some reserve extended communities will be things we want to push through the working group. Thank you, Wes. In May, we'll be looking at the last calling, the custom decision, and the RTC no RT, which I hope you'll be in town at that time when we do that draft, Eric. And we'll be glad to, working group last call, any document that has 2 implementations. Okay. How about now? Better? Okay. Thank you very much. Okay, John, why don't you hit the next one? I'll see if I can keep this on time. Okay. Come in, please, and we'll try it one more time. We are very tight today. Everyone who has an empty seat, please raise your hand. Okay? Feel bold because you'll be sitting up, standing otherwise. Lucy, there's one up here. And there's some up in the front here. Okay. Back to the agenda. Rob? I've even got one up here for you so you can't get lost. Niece and Rob, there are a couple too up here in front for you. Okay, we're going to hold a couple interims. Anise, I've got a seat up here. I'm serious, there isn't. Cool. John, go back one. There will be a couple interims. Please read the interim dates and the times. Okay, Wes, we'll see if we can get some more people, and then it's your turn.
Okay, next slide. So this went through working group last call and everything looked pretty good. We got a couple comments from the AD review, got good technical comments from a number of different folks, but when it went to IESG eval, it kind of went off the rails a little bit. Got some pretty substantive comments. I think that the top one is basically resolved. It was, Pete Resnick asked, are you really sure that this needs to be a proposed standard? We explained why. He withdrew the discuss, so I'm assuming that means it's fine. The other ones were really, they primarily came from Adrian's abstain on the draft, and that was sort of proxying Alvaro's review as incoming routing AD. These are sort of the main things. I'm just sort of summarizing them here. That the beginning of the document had too much of a focus on business justification and drivers on why we'd want to do this for a document that's supposed to be a standards document, and that we focus too heavily on discussing how the existing implementations work rather than discussing what the standard is supposed to do, and that we were not careful enough about using examples that favored one vendor's implementation over another such that it looked like a sales pitch or playing favorites, even though that really wasn't the intent. Those are the concerns that have been raised. Slide. The intro resolution is pretty straightforward. The main concerns that I saw in the comments that we got back from other folks on IESG was that our references, specifically the 95% billing and other things like that, were really not helpful to the overall discussion, and so it's pretty straightforward to just yank those out. Though I also got feedback that said, look, you don't really need to prove why this needs to be done. Just say that it needs to be done. And so I'm looking for some feedback from the working group on whether or not that actually is the direction we ought to go. The reason we put some of the additional justification is that this is kind of a weird draft. It doesn't require interop. It is relatively straightforward, but it's documenting something that already exists and is already in wide use. And the only reason we document it in the first place was in order to make sure that future changes to the protocol don't end up breaking this behavior. Even though it's sort of locally significant. And so kind of what I'm looking for here is, is it okay for us to just say operators use this, don't break it? Or do we have to provide more justification than that? And obviously the text will be there in the previous iteration, so it's not like people can't look back if we decide we want to yank that text out, simplify the draft. So that's point one. Next slide, please. As far as the vendor implementation stuff, do nothing probably isn't a real option. Yes, theoretically these are no objection comments, but it is coming from the incoming routing AD, so the next time we send this through the IESG, the routing AD is going to make the same comments, and he has not said whether he will make these a discuss or whether he will simply say, I'm still not happy about this. So unless we really feel strongly that this draft is perfect as it is, we're going to end up making some changes. So what I'm kind of suggesting is we can make an editing pass to pull out some of the vendor-specific implementation stuff, stopping short of a complete rewrite. But that is the other option, is to basically rewrite this so that we're basically specifying this as if there aren't any existing implementations, and appendix all of the information sort of as an implementation report. That does represent a lot more work for your authors because of the fact that we're going to basically have to rewrite the document. But that's kind of where I'm looking for some guidance. Next slide, please. So one of the things that I was sort of concerned with in this idea of creating a generic implementation guide is that we're now in a situation where we're basically writing something that doesn't necessarily conform to any of the existing vendor implementations, and thus, as this RFC gets published, we're now in a situation where we've taken something that was already implemented, and all of the major vendors are now out of compliance with it. Now, IETF isn't the protocol police. We don't have any say in compliance and those kinds of things, but what I find is that generally, when I'm specifying features that I want a vendor to implement, I will use RFCs as shorthand and say, implement this in the following way or whatever. And when it comes to things like RFPs and whatever, those serve as sort of litmus check boxes. And you don't want to be in a situation where you're asking vendors to say, yes, we're in compliance, but, and have to explain, or no, we're not in compliance, but. And so I'm kind of posing the question, does that matter to the vendors? Do we care as IETF if that's a problem? Ultimately, I'm kind of looking for how do we get the document to good enough to meet the goal, which was to document this so that we can make sure that it is in the IETF standards base, such that as things like CIDR, BGP-SEC, and other changes to BGP in the future happen, that this is documented well enough that it doesn't inadvertently get broken. So next slide is where I shut up and you talk. And if you can't get to a mic, we can pass one to you.
John Scudder. I prefer the approach of not retroactively making vendor implementations broken. It doesn't really seem like it helps anyone at all.
Yeah, and I think I mainly am going to need some guidance on how to thread that needle, because I already sort of had some issues in this document where, because, for example, Cisco and Juniper's implementations aren't the same, I had to kind of say, this is where things are similar, here's how things are a little bit different, without saying that either of the things were necessarily mandatory to implement. And I think we can probably do that. It's just, then you get into questions about terminology and other things. It's not an easy thing to navigate, so that's probably going to be one of those things where we're really going to have to look at how we write the text to do that.
On the question of whether you need justification for what the operators say is a requirement, I would say is you put in as much justification as you possibly can. I'm often asked why some spec that I wrote has some claim in it or says something in it, and if I can't remember, it's so embarrassing, right? And we'll need in a few years where I think it would be very helpful to have that justification in there. On the question of whether to invalidate vendors' implementations, well, I say, well, it depends what the vendor is, but you might want to not do anything that will be looked at as favoring one vendor over another.
Okay, and that was Eric Rosen at the mic.
Sriram NIST. So this is a standards track, right? So I'm
Yes.
just wondering if you have considered standards track versus BCP informational.
Yeah, we talked about that in one of the previous IETFs, and the decision was to make it standards track because it is providing normative guidance on what BGP is supposed to do, even if it's only locally significant. It doesn't require interop, but it does say, in order to do this, you must do the following things. And also, there is a subtending draft in CIDR that very much is making changes to the protocol behavior and is very much a standard. And it is, then you run into downref problems if the two aren't both standard. So we just figured this was easier.
So I think one of the main things I heard you saying was, please send text.
Yeah, probably what will happen, because I do have a number of different technical bits of feedback that weren't controversial and I just need to integrate, is that I need to spin one more rev with my first crack at what this looks like. And then, yeah, I think it's going to be a matter of going through and picking apart the text with these concerns in mind and see what we can do. Alvaro, do you want to make any other comments, or have I summarized things pretty well?
Alvaro Retana, Cisco, no.
Okay.
No, just to clarify, when I read the draft, and I told you this, right? It read to me, like you said, go look at the Cisco website. And, Cisco pays for me being here, so I'm happy to go look at the Cisco website. But that is not what we need, right? For this to be a standard draft protocol, or standard protocol draft, which is why I made the comment, right? That we need to make it general, not just go look over there, because of course the website can change, we can go do other things, and then no one would be up to spec ever, right? So that's the only thing I want to avoid.
Yeah, and I mean, to clarify, the draft does have normative text that backs up most of the implementation guidance that's given based on a certain vendor's implementation. And so I think it does stand alone. It's just mainly a question of how much of the examples get carved out and moved out of the document to just use the standalone normative text.
So we're about out of time, but so it sounds like the plan is you're going to do another spin, and then I did hear you say a couple times I'm going to need some help threading the needle, so you're going to make some noise when you're ready for that help.
Yes.
Good. Thank you.
If someone's near the door and you can prop it open, it might be a favor to everyone to just prop it open.
Okay, so this is next talk about BGP-wide communities and registered-wide communities. This is long work with many co-authors, and many of you actually contributed to both of those documents. Next one. Brief agenda, what I want to cover. Next one. The goals of this work is actually to simplify policy in BGP, which BGP is pretty much mostly about. And we're doing that by adding a new attribute and specifying TLV and sub-TLV within that attribute. The TLV consists of fields which you include in the BGP updates, which can be used as the input to the policy you're applying on the edges. And that effectively makes your policy of the edges simplified. Today, you don't have any comparable alternative to do that. The space of the communities is divided in two chunks. It's 4 octets. One 31 bits is for registered space. The other is for private space. So even if it's not registered, you can still use it and advertise on your web page as you do today with regular communities, for example. And this is not intended to replace standard or extended BGP communities. So this is just complementary work for that. Next one. The original proposal started at the Maastricht IETF, and it was pretty much my work with Hannes. Together, we proposed the document. The feedback of the working group at that time was to split the work, make the base specification of the encoding, and make another document for registered space for IANA maintaining the communities. And after that, I did the split, presented in Beijing IETF, the splitted work, and from that I got a lot of input, especially from help with the Jeff Haas here, as well as the Andrew Lang, who was author of the similar work in 2003. So what we did through this 5 years of time, which is a long time, we actually went through a number of discussions and iterations how to encode the communities. One of the ideas which we had was to include the algebra logic inside the community. And to some extent, it is not difficult to actually develop or to propose in the paper, but we found out at the end of the day that, first of all, there is never-ending story, and second, that it may be difficult for operators to actually use such algebra encoded in the communities. So we reverted back our work around Berlin IETF to actually use simple encoding, which was originally proposed, in the type 1 TLV, which we called container. Next one. And that's actually the attribute schema, which includes hop count just for limiting the propagation radius. Next one. So this is the container type 1 I meant to say, and it includes value, as I mentioned, source AS number, context AS, which can be the author of the private space of the community, as well as number of optional TLVs. And those optional TLVs consist of sub-TLVs, which we called atoms. That was invention of Jeff, which thank you very much. And those targets and parameters are optional, of course. As you will see in a second, there is a number of use cases which don't need to include those parameters, but those parameters make it more universal altogether. As far as algebra side, if someone believes it's needed, then the attribute is ready. There is a very easy way to actually define the new type and propose an algebra encoding in a new draft. So the work is very extensible if need to be extended further. Next one. For sub-TLVs, including, we went through a number of iterations, and we concluded and agreed among all co-authors, and actually many of you from the list, for the 8 types of different values which can be useful for BGP policy. Next one. So this separate work is actually documenting some of the input from the working group which I have received with what is useful to have in BGP as the wide community. It is entered as 00 just because my previous email address was not able and the IETF tool failed to make it 02. But this draft just lists the communities. Next one, John. Yeah. And you can see that some of them don't have any parameters or targets in it. Some of them have a very basic one, like the target AS number of the peer you don't want to advertise it to, and so on. So from the source perspective of your BGP peerings, you can inform which update should go where without going everywhere in your network to make the policy like today you do by hand or by script. Next one. This is just another set of registered communities, and we defined so far 22 of them. I spoke today with Russ about the 23rd, maybe useful. So we can also add it to that document, which is a separate document. Next one. So conclusion is the encoding has been pretty stable for the type 1 as we have today since Berlin IETF, and we don't plan any changes of that. If other types are to be defined, it's a separate work. There is no IPR on that, as far as I know, so just for information. And at this point, we decided to present it and ask for working group adoption. Pretty much, I think we either adopt it now or we forget about it and never move forward. So that's the status, and I'm willing to get more comments, feedback on the list or on the mic or. Silence.
We will definitely take the adoption call to the list, unless anybody has any comments for the mic right now.
Okay.
Thank you.
Yeah. You want this mic? Yeah, okay. I can hold it.
AC Lindum, Cisco. I was just looking at the registry and the 23 values. Are they the applications? Are those described any place?
Yes. Yeah, this is 2 drafts. One draft is the encoding. The other one is the application plus the register type. So the registered value draft has these use cases described. Okay. If it's not enough, let me know or let us all know on the list and we can add more, right? Okay, thank you.
Thanks, Robert.
There are blue sheets back there. People standing out in the hall, you're welcome to come and sit up in front, up against the wall, but we're pretty tight. Is there anybody with an empty seat next to this?
There's one chair there.
There's one chair in front. I'm serious.
Oh, right. You can sit behind the Meet Echo laptop.
Sandy, we're welcome to have you up here. Or anyone else?
There's a standing room right here.
Or sitting room on the floor behind us. The chair's a little long.
Let me take this interval to remind people that if you haven't signed the blue sheet, please do.
We would like not to be in the same position next time.
Okay, and let's have Stefan start now.
Okay, thank you. So I will present you the updates regarding the BGP timestamp draft. Next slide, please. So just to a reminder about the problem statement, what we are looking for is a solution to be able to monitor how much time does it take to propagate a path within a BGP control plane. Next slide. So the proposed solution that we presented in Toronto is to use a new BGP attributes, so the BGP timestamp attributes that will be able to record at each BGP speaker what is the timestamp to receive it. And now we add the timestamp also to when we send the BGP update. Next slide. So what we changed in the current version, so based on the comment we had in Toronto, we added the ability to set the egress timestamp to each peer. So based on some analysis, it sounds that it's possible to do it in at least in some implementation. If some people that are implementers have some issue with that, please let us know. The other comment that we had is about creating churns, because we are creating new attributes that are really different for each prefix. So it may create some churn. So to limit this, what we say is there is something in BGP saying that if you are trying to send an update and if the information is different from what you sent before, you need to send it. But if it's equal, you should not send any update. So what we say here is BGP timestamp is just an information. It does not have any impact on routing. So if only the timestamp is changing, do not send an update. About the update packing also, we think that this is not an issue to break packing for this timestamped path, because it's just few prefixes that will be monitored, so it's not really an issue if you break packing. We also changed few things in the encoding, but clearly today the encoding is not really critical to me. I just want to focus now, or is it really useful? Is it really the good solution to provide this BGP control plane monitoring, and then we can discuss bits and bytes regarding the encoding. Next slide. I also had something about the state information, because sometimes in a BGP control plane, even if you are trying to send a single NLRI, within the BGP control plane, if you have multiple ASBRs, multiple route reflectors, you may have multiple BGP paths. So depending on the order of reception of each path, you may receive some old timestamp information. So we need some things that say this is an old information. So we are adding this state indicator within the timestamp vector. About the next step, so we are requiring your feedback. We are also requiring feedback for BMWG people. I sent an email to their mailing list. Unfortunately, I don't have any feedback yet. We will also present it in Grow, because I think it may be useful for them to have their feedback, and maybe to home the problem statement in Grow. So if you have any comments, if you find this could break some implementation, do you think it's really accurate? I think it is accurate. If we are doing sampling, it should work. So I'm open to any of your comments. Robert.
Robert Raszuk. So I like the work in general. This is very useful, I think. But as the first reaction on your first presentation of that idea, I proposed the BGP path record attribute draft with Ras and Jing. So I think that it will be good to have one attribute doing record of various things, not just timestamp.
Yeah.
So I wonder what is your opinion about using this kind of encoding.
I have no issue of using this. As I said, encoding is not my first focus for now, so we can discuss. The only thing I'm wondering is that if you are trying to record something else at the same time, you may impact the timestamp.
Well, it's about taking information and carrying it, right? It's not really, it's the way you carry it.
Yes, but if you need to timestamp, I think you need to keep this timestamping action as lightweight as possible. But in terms of container, I have no issue to use some generic container. But if you want to record next stop, for example, as a timestamp at the same time, it may delay a bit more your BGP update processing. But using the container is not an issue.
Okay, Robin from Huawei. I need one thing to be clarified, so that when you record the timestamp, what mechanism will you use for the clock synchronization?
For the what?
clock synchronization.
Whatever. Whatever. It's the local. It's no. It's the clock is given by the information that is within the router. So if the router is synchronized using NTP, it will be the time that is provided by NTP. And we have in the encoding something that says this clock is coming, for example, from NTP or from something else, just to ensure that the nodes and the different timestamp provided could be correlated between each other, because you may have some BGP speakers that are unsynchronized.
Yeah, but that's because we know the BGP route always span multiple AS.
Yeah.
Yeah. I think that they may have operated by different carriers. So I think I think the accuracy of the clock synchronization.
Completely. That's why in the encoding we are providing an information about how each BGP speaker is synchronized.
Okay.
Any other comment? Next presentation, BGP RTC inter-AS. Next slide. So I also presented this problematic in Toronto. So the issue we have today with RT constraint is in some implementations, when you have a disjoint AS, for example, the 65,000 here, so the RT NLRI is propagated correctly, and when I have, for example, a route reflector, the route reflector will perform some path pruning, saying that I will only forward the VPN information towards the shortest path to reach this AS. So in these specific scenarios, the CE1 will not be able to exchange VPN routes with CE2 because of this path pruning. Next slide. So based on some discussion we had in Toronto and also after, it sounds that the interpretation of the base RFC is not really easy. And in fact, we can see that all the implementation sounds to be compliant with what has been defined. But for sure, we have some differences and we have to deal with this issue. So what we done is we completely rewrite the draft to explain, okay, what's the situation today? We have two kinds of implementations and reading of the base RFC. So we have the implementation which is doing the peering type base pruning. So if I'm doing pruning for eBGP session only, but if it's an iBGP session, I will never do pruning. And we have the other type of implementation that is doing pruning based on the NLRI type. So if it's external, I will do some pruning, and if it's internal, I will not do pruning. So we are explaining what are the pros and cons of both approach. And so, for example, the NLRI type based pruning is providing some path saving within the BGP control plane, which is good, but as a drawback, requires some more convergence in case of failure or some stuff like that. So we really reoriented the draft to explain more the problem here, and we are keeping the solution that we presented in Toronto. So if you are using the NLRI type based pruning, the implementation must give the ability to disable it for specific ASs. So we are wondering if there is some other comments regarding this issue, how we handle it, how we present it in the draft. This is something that we need to solve, for sure. So is the solution fine? But I think we have now sort of consensus of the understanding, at least, of the problem. So I'm requesting the working group adoption for this issue. Yeah.
Yep. So again, we will do the working group adoption request on the list. Just sort of speaking as a work group member, to me it's perfectly obvious that we need to adopt this because it's a real problem. It's a fairly straightforward solution. Even if people don't like the solution, they surely must agree that we ought to fix the problem.
Yeah, we need to find a solution.
Any other comments?
Could someone hand the mic in?
That's okay.
Okay.
So is that related to the pruning of the hierarchical architecture?
It's different. It's different. It's similar but different.
Just for
This is the last one.
for other people making comments, it is a small room, but people on the other end of the audio flow can't hear you unless you talk really loud. So please use the mic anyway.
So flow spec interface set update. Next slide, please. So what is the goal here? Today, if you are deploying BGP flow spec, you send an update, and it will automatically be used by all the routers that are running within this BGP flow spec control plane. So all the routers will implement the filters. But sometimes you need to have more granularity and say, okay, I want to install this filter only on specific interfaces and moreover in a specific direction. So we are proposing here a very small extension that will permit to say, okay, I will tag my different interfaces using a kind of group ID, and then I send an update and say, okay, I want this filter rule to be applied only on this specific set of interface. It's just as easy as this. Next slide. So since Toronto, we fixed a bit the text based on the comments we had. So we justify why do we need also this ingress and egress filters. We also providing some guidelines about interactions with some filters that may already exist on the interface. So for example, if you have a flow collection using a BGP NetFlow, you need to apply this filtering, and you need to keep the information about flows. And for ACLs, also some guidelines to say we must not mix the permanent ACL with the dynamic filtering that is provided by BGP flow spec. So next slide. So next step, if you have any other comment, we are welcome. And we ask also the working group adoption for this very, very simple and very, very useful extension. Any comment?
And of course, once again, we'll take the adoption on the list. Unless there's any questions or comments, I'll ask.
So, AC Lindemann Systems, I haven't gotten a chance to read this draft, but do you offer any guidance for how to group the interfaces? Because I can see for one flow spec, because the interface group is a local configuration, right? Right. So you would have to have a predetermined way of grouping these interfaces for applying the flow specs.
What we are targeting is something really manual, in fact. For example, some use case that we are targeting is being able to maintain some ACL within the network. So if you want to be able to really quickly update some infrastructure inbound ACL for your internet customer or for peering points, you just flag your interface and say, okay, I will apply this filter to all these kind of interfaces. Okay, so interface type, yeah.
Hello, my name is Stefano. I'll give you a very rapid update on the BGPLS EPE extension. Next slide, please. So as a reminder, what we want to do, we want to model the topology, the inter-AS topology, the peering point topology, by defining this into BGPLS. We are now on after the merge with a similar proposal, and we agreed on a common encoding scheme. So we simplified probably the way we encode this into BGPLS. Why do we want to do this? Especially for segment routing, we want to be able to assign to a peering resource a link, a peering node, a group of links or group of peering nodes, peering autonomous system, and so on, a segment identifier that you could use at the ingress, so to steer the packet not only to a given BGP next hop, but also through the resource that is attached to that particular BGP next hop. So next slide. The change we made is just the use of protocol ID in BGPLS. Before that, we had in the previous version of the draft the use of a separate NLRI type, and after some discussions with the author, we agreed that protocol ID would be the best choice for everyone. So that's what we did. For the rest, nothing has changed. So the resource is described still in the same way, with node descriptors, local and remote, so the local BGP speaker and the peer, and all the link descriptors that have been already defined in BGPLS. So we use BGPLS for what it has been defined, so a very nice toolbox to describe and model a topology. Next slide, just what I said. So next slide. Any questions, any comments? There is already at least one implementation, I know. I don't know if there is a second one coming up. Otherwise, we'd like to see if the working group could consider the adoption as working group document. Yes?
My name is Zuma from Ericsson. So from the slides, I'm not able to understand which NLRI you removed and this TLV is placed into which NLRI. I understand from the document changes, it's link NLRI. This TLV is introduced in link NLRI. Originally, you have new NLRI described, which is peer NLRI, right? But it's not clear actually. So I would request you to see your INA considerations and clean up a little bit.
Okay.
And also, this is applies to. Of course, I should not talk this on the BGPLS original draft. The code points are defined in the subsections where being described. It should be consolidated into INA actually. So in the BGPLS draft, there's a link which says go see there. That link doesn't work. It's better to describe all.
The guy is behind you.
The same problem here for this draft too.
Okay.
It's in the inside the text. It's being described code points.
Okay, I take the point. Yeah. That's it. Thank you.
Okay, so myself Pushpashi, for those who don't know me. So I'm here to talk about node admin tags. This has been introduced in previous IETFs in the the ISIS and OSPF working group already. So this time this draft talks about introducing this in BGPLS. Next slide. Okay, so I'll be going through some prior art, and then we'll discuss about the current draft proposal. Next slide. So some prior art, why we need node admin tags. Actually, the goal was to basically represent some a tag or basically a node characteristics using some kind of tag. But when we looked at the existing ways for that, we found one as the link colors, but a link color doesn't really represent a node. So and then if you really want to do it, you have to color all the links with that specific color. So next slide, please. The other one was prefix tag. At the time of earlier discussions, the prefix tags only applied to ISIS, and there was no SPF1. We got recently an OSPF1 prefix tag. But again, we have most of our TED implementation not aware of prefixes, only nodes and links. Next slide. Okay. So what is a node admin tag? It's basically a 32-bit unsigned integer value that you associate with your nodes in the LS link state advertisements. And we have already have these drafts, ISIS node admin tag and OSPF node admin tags. These are already, adopted by the corresponding working group as a working group document. And basically, like I said before, the tag is like it's basically represents a node characteristic for a given node in the network, and you will basically use as many number of tags as the number of type of characteristics that you need to use. Next slide. Use case, mostly it enables applications that needs to group different nodes in in their network with different capabilities, and they want to advertise that across the entire topology. Again, some details as to how you tag them. Each characteristic type stands for one tag value, and then so all the nodes that exhibits that same characteristic, you tag them with the same tag. And if a node exhibits multiple type of characteristics, you tag them with all those relevant tags, right? Next slide. Okay. So now we were talking about a tag, but then it's basically just a number which is only up to the interpretation of the network operator, and they should be unique. The meaning should be unique across the entire network in the IGP domain, and it should be independent of the order in which you tag them in your link advertisement. Use case facilitates any routing applications that require advertisement of certain characteristics. And again, one part we actually been telling about is that it doesn't need to define well-known values. You can use it within your domain with any significance that you agree upon. Right. Next part. So this was the TLV sub TLV we added in ISIS router capability TLV for getting the node admin tags. Next slide. And that one was for the OSPF, where we added a new TLV under OSPF router information LSA. Okay, so coming to the current draft proposal, we basically look forward to each BGPLS speaker to learn all the node admin tags from its IGP databases and TEDs, right? And then reoriginate them into the corresponding BGP-LS advertisements using a new node admin tag TLP that we have introduced, and then putting them into the BGP-LS attribute of the corresponding BGP node in NLRI, right? So that's for the speakers who are attached directly to the IGP area, and then remote LS receivers like a controller can actually participate in that and learn all the node admin tags of the entire topology across AS, across area, across levels, right? So like I was saying, it facilitates all kind of applications, including intra and inter-AS applications. Slide. That's the new node admin tag TLV that we have proposed. We have actually, if you take a note, there's the just after type and length we have the 16-bit of flags, and currently we have added a just one flag there, but can be expanded later on. I'll show you in the next slide. I'll illustrate how this current bit is being, or flag bit is being used. Next slide. So that's some guidelines. So when a BGPLS speaker, when he gets node admin tags, so this node admin tags come in basically either in ISIS it comes under router capability TLV, and they are either per level or per area in the case of OSPF. They have per area scope, or they have a domain-wide scope, right? What this means is that what we are trying to say is that when you basically accumulate all the per area or per level admin tags and attach in a single node admin tag TLV under the corresponding BGP node NLRI, and use the flag, the L bit in that corresponding flag as 1, which means these are all These node admin tags are all per area or per level scoped, and then you have another node admin tag TLV where you copy all the domain-wide labels learned from that node, and you put it into that tag TLV with L bit set to 0, which means it is they have all domain-wide scope. Next slide. And yeah, so any comments, questions? I've already got one comment from Uma. Yeah, I'll take care of it. Yeah, we'd like to, this is the first version of the draft. We'd like the working group to actually to read this draft, come up with comments, but to us, I think it's quite so far complete because we have worked out a few things also in the corresponding ISIS and OSPF working group. So if we'd like to ask for an adoption as a working group draft.
There was a question, I think, in the back. Is that still there?
Robin from Huawei. I have one question to be clarified regarding this draft. According to my understanding, for the IDP-based node admin tag, I think the application seems apparent. But I think here mentioned that BGP-based node admin tag apply to any inter-AS or inter-area application. Can you give an example? That means inter-AS TE or inter-area TE or like this.
So you, I don't have solid examples of how to use them, but I know there have been interests, say, to know the topology, inter-area topology, right, awareness, as well as sometimes you have applications that need to know, even though it is sitting, out of the AS, it needs to still know something within the AS. So all that kind of applications can, benefit from this. But I don't have a,
Stefan from Orange. Just to respond to your comment, yes, for example, in our use case, we are owning multiple ASs that are interconnected together, and we may use the same allocation of node admin tag, for example, for geolocation of nodes. So we want to be able to apply inter-AS policy, so saying for going from this point to this other country, I want to avoid another country, and I want to apply this policy globally to all my ASs.
Any other questions or comments? Great. So as with all the others, working group adoption will be discussed in the list. Just as a comment, we're getting a lot of people presenting today asking for working group adoption, so we'll be staggering those out because otherwise the workload would be staggering for all of you to read and evaluate every single one of them. So yeah, following this meeting, we'll probably have a whole rolling series of working group adoption discussions. Okay, thanks.
Thank you.
Hello. One. Okay. So this draft is about advertising capabilities of the BGP Next Stop. Next, please. As an introduction, I'll start with a recap of RFC 5492, which allow advertising capabilities in BGP4, but it advertises capabilities of the BGP session, so it's related to mostly control plane on the session. And in general, the BGP peer is not the same as the BGP Next Stop, especially when you use route protection, route server, or Next Stop unchanged. So it's not a way to advertise the capability of the Next Stop. Next, please. So the draft proposed to define a new non-transitive BGP attribute, which carries a set of Next Stop capabilities, and each capability is encoded as a TLV. So in short, this is the same encoding as BGP capabilities, but it's carried in a BGP attribute. Next, please. So regarding operation of this attribute, we need and we must have that capability removed when the next stop is changed, because we want to make sure that the capability reflects the capability of the real next stop. not the past one. So for compliant peers, the draft defines that if the next step is unchanged, the capability, the attribute should be passed unchanged. And if the next step is changed, the attribute must be removed. Obviously, you can add a new one to reflect the capabilities of the new next step. And for non-compliant peers, as we use a non-transitive attribute, the attribute will be removed as per regular 4271. Sorry. In terms of error handling, currently the proposed error condition is a mismatch of lengths between the length of the attribute and the length of each capability. In terms of error handling, it's proposed to be attribute discard, but this is assuming that implementation will not allow changing the preference of the route depending on the capability of the next step. So this is something that we need to discuss, because this is a restriction. Next one, please. So there is another option, which would be to define a new capability for each new application. So I have a new application, and I want to advertise the capability, and I define a new attribute. I believe it's easier to define a generic attribute. First, it's easier for IDR implementation, because we do the job only once. And more importantly, it's better for the application, because it allows for incremental deployment. Because if you define a new capability for your new application, the new capability is not known to your peer, and it will be removed. Next, please. So that's all for the attribute. So the document also defines a first next step capability, which is called entropy label. And the capability is sent if either the BGP next step is able to handle the entropy label, or if the BGP next step will perform a swap, MPLS swap, and hence doesn't need to see the entropy label. And when you receive that capability, it means that you may send a packet with an entropy label to your BGP next step. So this is not really new. It's based on the ELC BGP attribute, which has been defined in RSC 6790, but then deprecated. So we'll have to define it again. As an option, we may also or not want to advertise the readable label depth, which is a number of labels that a transit LSR is capable of reading to perform load balancing. So we may define it in a different capability or as a value field in the entropy label capability. So it's probably better to define it a different one, because it's a bit independent. So that's all. So I'd like to have comments and feedback.
Hannes Gredler, Juniper. Actually, we have been discussing very similar proposals in the IGP for entropy label support, and the semantics of those advertisements is that you only advertise, for example, ELC support if all your interfaces are going to support this. So I can see some analogy here, right? What the BGP session really advertises is a sort of node property, and you try here to break it down to really per interface properties, which is all good and great. I just want to point out there is right now a discrepancy in the models between protocols. So in IGPs, it's really a node capability, and we only may advertise ELC capability if all interfaces do support it, and there is no sort of selective model here.
Okay, it's good point. Here, the easiest option is to also take the node capability. We could go into more details and make a distinction between eBGP peer and iBGP peer. Mm-hmm. So if you send it over eBGP, you would only need to support it on the eBGP facing interfaces. Mm-hmm. 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 But maybe we don't want to go into such details, so it's a point to discussion. But it's a good comment. It should be added in the document. Yes.
So we have a question from Jabber from David Lampeter. This is used on each individual route. how does this relate to draft IETF IDR BGP next hop cost? Would it be possible to use in the new SAFI introduced by that?
So it is used for each BGP advertisement, so it's per route, and I will need to check the aforementioned draft to see the relation. Can you send it on the mailing list? Either Jeff or the editor?
I will ask them to put it on the mailing list.
Thank you. So because I don't know the draft per... Okay, thank you.
Not my turn.
I thought
Okay.
you are next.
Previous slide. John, previous slide. Okay. So, Robin from Huawei, I have one comment. That when you explain this, the capability, that means the entropy label is only to be processed in the BGP next hop, not in the internal.
No, yes, it's just for the BGP next hop, yes.
BGP next hop.
Because if you use a tunnel between the ingress yourself and the BGP next hop, every node on the path will not see the entropy label because it will be encapsulated in one or multiple labels.
Yeah, but
so
but the purpose may be changed because once you encapsulate the entropy label, because your original meaning is to process the entropy label as the next hop. But once the entropy label is encapsulated, even in the internal network, it will also process the entropy label.
It's by process, it depends what you mean. It will be seen during the load balancing.
Yeah.
But if you don't understand it, it's not an issue. You will see it as a regular label. But you don't have to decapsulate the label on the ingress. In that case, you really need to understand it because you will see it in the top level. You need to do something on that level. And if you don't know what to do with, you will drop the packet. So you need to distinguish the processing on the ingress or on transit. On transit, it's not an issue.
Okay, but because in my opinion, entropy label, it can be processed globally. Because once the ERI is encountered, any routers can support the entropy label, can process this label.
Again, by process, you mean look during transit or remove as egress? Because it's two different things.
Okay. So another comment is.
Wait, I'm sorry. I was not expecting many comments on that part because it's mostly a copy paste from an existing document. So
yeah, I was actually about to say if we can cut off any further comments about entropy label as such, because that's not normally what we work on in this group. I'd be more interested in talking about the container idea, and I mean the entropy label stuff is important, but let's. Yeah, right. It's already had one spin cycle with RFC 67, whatever it was. So if people have comments on something other than the entropy label aspect of the draft, I'd prefer to hear those first.
Okay. So the next comment is that because previously we proposed another draft to record the next hop because we will record the next hop list for the BGP route. For your next hop capability, you just only one capability, or also use the list of the capability of the every next hop?
There is one attribute. In the attribute, you have a list, a set of capabilities, just like for BGP capabilities advertisement or for BGP session. So we have any number. Well, it's limited by the size of the attribute, but you can advertise many capabilities.
Okay.
K. Patel, Cisco. Do you need a text here that says if the route reflector is in forwarding path and doesn't support this, you may need to strip this attribute out?
No, I don't think so. In the forwarding path, you mean it change the BGP next hop?
Yes.
So if it change the BGP next hop, it's a regular processing. If you can come back to the slide about just one more. Capabilities operation. So if you change, if you're not compliant,
Okay, so
you remove
attribute
that.
has to be stripped.
Yes, but it's not specific to root affection. Yes, it's if anytime you change the next step, including if you are in root effectors on the path.
Okay, and we're out of time and seemingly out of questions also, so perfect. Thank you. And it's an approximate topic.
Okay. My name is Anish Sheikh. I'm going to talk about an update that we've made to the BGP model from the Open Config Working Group. Just to recap.
One sec. I'd like to ask if you have a side conversation to have, if you can take it outside, please. Thank you.
Go ahead to this one. So just to recap what we presented in Honolulu, the Open Config Working Group consists of a bunch of network operators who are informally working together to define data models and other mechanisms for improving programmability of networks. So one of the things we started working on was a BGP data model built in Yang. So these models are built out of operators essentially examining their own configurations and operational parameters and including these in the model. And we've been trying to make these things vendor neutral in the sense of looking at items that are available in a broad set of implementations that are used by these operators. So the model scope includes a number of things. We have base protocol configuration, and it's a hierarchical model as most BGP implementations are. So there's global level configuration, per neighbor configuration, as well as support for peer group templates in the model. There's also support for multiple address families. We have a number of AFI-SAFIs defined, and it's relatively easy to extend it with additional AFI-SAFIs as we want to add them. There's support for BGP policy in conjunction with another draft that we're going to present in RTGWG this week, which describes a generic routing policy model. Now, the BGP policy model basically augments that generic policy model so that these two things work together to create BGP-specific policy and also can leverage some of the generic policy mechanisms described in that model. And then we spent some time actually also defining operational state for BGP. So we don't ignore operational state. We're trying to include it as first class, although we've still got a ways to go to add more operational state data to the model. So what's changed since the initial revision? A number of updates to the model in the current draft. There's a new structure for operational state. So this follows the convention that was described in the draft that we submitted to NetMod and was presented earlier today on operational state. If you're interested, I encourage you to go have a look at that. The whole AFI-SAFI configuration has been restructured to be much simpler and flatter based on a number of feedbacks from various people. There's support for sort of generic AFI-SAFI configuration across all of the address families, and then there's a per AFI-SAFI capability to configure specific address families. We've separated out, originally the model had BGP policy sort of mixed in together with overall policy. As I described earlier, we've now separated that, so there's generic policy and BGP, and these things come together to create a broader policy model that can be used across multiple routing protocols, including BGP, of course. And there's a number of new base protocol configuration items. I guess most importantly, we have received a lot of feedback on the model from implementers. So we have actually several engagements with vendors in progress on implementations. There's a lot of changes in the current version of the model based on that feedback. If you're interested in who's provided feedback, there's a long list of acknowledgments in the current draft. That feedback has been related to things like model structure itself, where different configuration items are located in the hierarchy, whether they should be global, per neighbor, etc., and then support for specific features and some feedback on, how widely supported certain things are. And there's a number of other things as well that I don't have time to get into. There's a question about, there's another draft that Keir is going to talk about in a minute. We've had a number of discussions with co-authors of that team, in particular Keir. So there's a few. There's a summary of some of the feedback and differences in the two models. We talked about this in some of the interim IDR meetings the last couple of months. I think the other model doesn't really address a routing policy, largely because of differences in implementations. We actually are trying to address policy directly. We don't believe BGP is that useful without policy in the model. And operational state, we also spent a fair bit of time trying to refactor the model in this revision to support expression of operational state as well. There's a number of structural suggestions that have come from those discussions. We've actually added most, if not all of those. So I think that there's a good deal of convergence that's happened between the last revision and this one. And for folks who want to have a look at the modules, they're available in this public GitHub repository that's in the slides. That's it. Yeah, if there's any questions on specific structure, there's a few diagrams in the slides that show that. Any questions?
And we do have a little time reserved after Kair's talk if we want to have, discussion about what does the working group want to do with regards to moving forward with the model. But if there's anything specific to this talk, please ask now.
Thanks.
Kair Patel, I'm going to talk about yet another data model for BGP. Next slide, please. So the update from the last IETF is that we've changed the draft name from NetMode BGP to IDR BGP, since all the protocol related work is going to be handled by the respective protocol working groups. We have also added co-authors from Huawei, Ciena, and Ericsson, and we've incorporated comments from Adam and Gunter. Next slide, please. We've made following updates to the model. We have added protocol version within BGP protocol itself to rev the models in future. We didn't include neighbor groups in the 0.0 version because we thought it was esoteric to certain implementations only. Apparently we found out that it exists everywhere, so we've added it. We've added the neighbor-based transport parameters, and then finally route flap dampening support. Next slide, please. Here's how the new model looks like. We have update groups at the same subtree level as BGP neighbors. Essentially, the detailed model is in the draft. Next slide, please. So these were the major differences from open config model. We had neighbor lists wrapped around within containers versus a open straight list in open config model. We had neighbor groups also as a container with neighbors referencing to the groups, which was done differently. Again, global address families were containers for us. And then we thought import-export semantics are very specific to L3 VPNs, and that's why we had left it out. We had redistribution. Next slide, please. So, like Anish said, we've been talking to Rob and Anish again. Most of these differences have been resolved. Open config models have incorporated quite a lot of this differences, and at this point it seems like the high-level tree structures are fairly similar. Next slide, please. So plan on moving forward is to get a rev, hopefully that replaces quite a lot of enums with identities. They help avoid model revisions. We want to use deviations to harmonize command parameters. This is a very detailed work that we want to take on, but we probably want to do this change a last one once we have cleaned up everything else. Of course, use of any features for any vendor-specific esoteric features that we have had. And lastly, look at the upper state model. At this point, both the drafts have taken suggestions from each other, and they've been following very closely. So I would suggest, given an opportunity, we should consider working towards a common draft with maybe a design team between vendors and operators and get this thing hashed out.
So that is the intent of the working group, to have, or the chairs to have a design team and to make sure we come out with one draft fairly quickly. If someone's interested or has any questions, please contact the chair or send mail to the list.
we're going to keep talking to these slides, or?
I'm good.
This is now the time for questions, if you have it. We have a few minutes. We'll go next then. Thank you.
My name is Sriram, and I'm from NIST. So this work has been in IETF since the Toronto IETF last July. So there we presented both problem definition as well as detection mitigation, and it was suggested that we split it into two drafts. We did that going forward. In Honolulu, we presented the problem definition draft in the GROW working group, where it has been accepted as a working group draft, so that is work in progress in GROW. So it was also suggested that we bring the detection mitigation part of it into IDR and present it here. Next slide, please. So the basic notion of a route leak is when a customer receives an update from one ISP and routes it back to another ISP. Basically, the update makes a U-turn. So we start with that and try to address, and this frequently causes problems. Many examples are there where this kind of a route leak has happened. Next slide, please. So we put it into 7 different types based on observations of real incidents that have happened in the internet over the past couple of years, even and going back even further. So these 7 types are clearly, and explained in detail in the definition draft, which is cited at the bottom. I'll just mention the names here. The details. For the details, I would like to refer you to the draft, the definition draft, and several real-life incidents are also cited as examples for each one of these. So the type 1 is basically a U-turn with the full prefix. Type 2 is a U-turn with a more specific prefix. Type 3 is a prefix reorigination, or you may call it hijack, with data path to the legitimate origin. So the prefix has been reoriginated, but the backward data path is still kept, preserved, or available for the data to go back to the legitimate origin. Type 4 is a leak of internal prefixes and accidental deaggregation. Type 5 is lateral ISP to ISP to ISP leak. Jared March observes these very often. Again, the references for his work are in the draft. Type 6 is leak of provider prefixes to a peer, and type 7 is leak of peer prefixes to a provider. So all of these are kind of valley-free violations, except for type 4. Next slide, please. So if you look at what is out there that might help with detecting or mitigating these route leaks. So this is a table which shows if anything that we already know can help. So the 2 things that we have available are origin validation and BGP-SEC path validation. That's work in CIDR. So type 1, type 5, 6, and 7, nothing is available in the form of, between these 2 protocols, origin validation or BGP-SEC path validation, they don't detect or mitigate, unless you make some modifications, as we will discuss. Type 2, 3, and 4 have some solution in origin validation or path validation, as the chart identifies. So once you look at what origin validation is, what path validation is, path validation is basically checking that the update actually traveled the set of ASs which are shown in the AS path. So once you, and that is protected by signature as well in BGP-SEC. So some solutions are available partially. So what we are going to try to do today is propose some changes in BGP or BGP-SEC that might address the entire set of all these route leaks cases. Next slide, please. So the sender specification is quite simple. What we are proposing is what we call an RLP field. The RLP stands for route leak protection. The RLP is proposed to be a 2-bit, just as a starter, but we can modify that as needed. But we think that might be sufficient for a good starting point. It can be carried in a transitive community attribute in BGP or in the flags field in BGP-sec. BGP-sec already has a flags field where there is space for put in several more bits besides its current use, and it's also protected under signature in that case. So once we agree that an RLP field makes sense, the way to use it would be, it should be set to one of two values, 00 if this is a default value, if nothing is specified, and 01 says that do not propagate this update upwards from for example, from a customer to a provider. So it should not propagate upwards from the next AS to whom I am giving it or any subsequent AS in the AS path. Next slide, please. We can have a variation of this, which we are calling method 2 here, where we can make use of, have a few more states. 00 is the default, nothing specified. 01 could say do not propagate up, 10 could indicate propagate to customers only, and 11 could say do not propagate or no export. So we can work on this and agree on the semantics, but the basic problem we are trying to solve is how to address route leaks, how to detect, how to mitigate. Next slide, please. So that's the end of the sender specification. So intent of the sending router is quite simple. So there is no explicit disclosure about the nature of the peering relationship. You may deduce it, but there is no explicit disclosure about that. And also, we are not looking up a table where customer, provider, customer, those kinds of relations. It's not coming from a database. Each AS is voluntarily setting this indication just to say that I'm sending it towards a customer, possibly towards a peer. Please make sure that this does not propagate up from a customer to a provider, for example. Next slide, please. So the recommended action in the receiver is to basically mark an update as route leak, and you would mark an update as route leak if these two things happen. The update is received from a customer AS, and the update has an RLP field set to 01. Do not propagate up indication for one or more hops in the AS path, but excluding the most recent. The most recent is the one who you are suspecting is probably doing the route leak. So you go back one AS before that to see if they indicated that this, or any other AS in the path, which is 2 hops or prior to that, if they indicated it should not propagate up. So that would be one simple receiver algorithm to mark update as route leak. Next slide. So that in the previous one, you would catch type 1 and 6 and 7. 3 and 4 we are not addressing because they are solved by other means, BGP origin validation. So the previous update addressed 1 and a couple of others. I need to go back to that list. But then the remaining ones are addressed here. So there is one interpretation of 01 which says that don't propagate it up. Another interpretation could be that if the provider is saying that I'm sending it possibly towards a customer or a peer, and if it should not propagate up, chances are that it should also not propagate laterally from a peer to peer. So after it has been sent from a provider to a customer, or from a peer to a peer, then it should not go another hop peer to peer, or it should not go up as well. So a little stricter interpretation can be applied in the receiver, in which case the 01 indication says that I would not also accept it from a peer if one hop before him said that it should not be propagated up. So next slide, please. So by doing that, we are able to label an update as, label as an update as a route leak. And once that's done, the receiver action for mitigation could be simply that if it's labeled as a route leak, then you prefer a peer or a provider update over the customer's update, for example. Next slide. So that's it. So this is incremental. So if you have a dozen or a 20 or 30 major ISPs adopt it, that will be a starting point, and it can grow from there. Next slide, please. So that's the summary. I'll stop there and take questions.
Keyur Patel, Cisco, this is actually a good solution. The question I have for you is, you know, a provider gives a route to a customer leaks it out to another provider because it's dual home, right? Does it make sense for providers, because providers know that the customer is a stub or not, does it make sense to just generate a AS path ORF and send it out and say, hey, just send me routes belonging to your AS only. Just filter it at your end and don't send me up. Would that be an acceptable solution as well?
Need to think about that. It seems to make sense, but I'll think, I mean, because we are short of time, I'll discuss the details with you.
West George.
Will you discuss the details on the list?
Yeah. Okay.
So I apologize. I know I've read both of these drafts, but I read a lot of drafts right before IETF, and so I may be asking questions that are covered in the draft, and you can certainly point me there. So you make in your taxonomy, which is, I agree, is really good, and I appreciate you guys doing that because it really does help give us a way to talk about this better. You refer a lot, like most of your definitions are relying on intent, but as far as I can tell, you never really define what intent is. So that might be one of the things you want to think about in the context of this. You know, in the other draft, you talk about up and lateral and things like that, but it's also not clear to me, and this, like I said, this may be in the draft and I missed it. How are you defining that? Is this something where I'm categorizing based on whom I'm peering with on the BGP session? This is an up session, this is a lateral session, etc. Or is there something else that I'm doing in order to categorize, you know, if I've laid this flag and said don't propagate this up, how do the routers that receive that flag actually know what up is?
So each, we are assuming the assumption is that each router knows the router that is sending the update, whether it's coming on a customer link or a peer link.
Well, but the problem
or
with
a
this is
provider
that the
link.
lines between customer and peer are sometimes a little blurry. And so that's why I'm trying to get, we've got to get a lot crisper about how we define this systematically, because if you do it just strictly on those terms, this is not all that more useful than the variants of things like no export and things where customers can send me community tags that say don't propagate to this AS or don't propagate to that AS. That we already have that route propagation filtering machinery.
Mm-hmm.
And so I'm sort of struggling to see how this would be, how this would work in those kinds of scenarios. I absolutely agree this is a difficult problem, and I don't have a good solution to it, which is why I'm up here saying I think we need to think a little harder.
Okay. Thank you.
But I think that's the other question there.
Okay.
And then the last thing is a few slides ago you had a thing about, you know, the different types of route leaks and which ones are detected or are mitigated by BGP-SEC and origin validation.
Mm-hmm.
I think you had a reference to RFC 7454 in the document. That's the BGP operations and security document.
Mm-hmm.
It would be useful to look at how many of those things also mitigate some of these problems, because you can look at about half of those things and say proper route filters and proper max prefix limits will fix about 90% of this as well.
Okay. Thanks.
Doug Montgomery, Nest. One point I would make to Wes's comment is there's a difference in a technique that's meant to prevent the actual leak and a technique that's meant to detect it and allow you to mitigate it one step away. And this was focused on detection and mitigation one step away. So we're not telling your routers how to figure not to send it up. We're telling the next AS upstream how to figure that you blew it, however you blew it.
Right, and that actually brings up another point that I forgot, which is, you know, one of the things that might be useful here is to identify things like anomaly comparisons. You know, one of the ways you detect this kind of stuff is to look at what the baseline was versus what it is now, and see what you can infer based on that information. Because a lot of times that's what's happening, is we look at this and we see what the table's supposed to look like. This AS talks to this AS, provides this information, but it's not propagated to this other AS. Suddenly that changes. We can now infer that there might be a route leak. We don't know whether it's purposeful or not, but we can at least determine it that way. And so that's another sort of...
So dynamism okay. Okay, thank you. And we would also like to request this for working group adoption at some point.
Okay, we'll add you to the queue. Since you didn't put that in your slides, if you can send a note to the working group chairs. Thank you.
Thank you.
Good afternoon, everyone. This is Robin. My topic is service-oriented MPRS path programming. This is related with two drafts. One is in the Spring working group, and another is the IDR working group. Okay, next one. Okay, I think this idea has been proposed in the Toronto about the service-oriented MPRS path programming. So here we just use a small introduction because the unicast, we can say this the service label can be flexibly combination with the prefix label. For example, the source label can be used for the OEM for the packet loss ratio. Steering label can be seen as the similar as that the EPE label that is for steering the prefix to go through a specific link of the inter-AS. And the entropy label can be seen another service is for the load balance for this prefix. Besides this one, and this is can also flexibly mapped to a transport tunnel because the transport tunnel is also the flexible service. So the flexible mapping of the prefix to the specific tunnel is also for the service programming. Okay. Okay, and here this is the architecture for the service-oriented MPRS programming. So here we need to use a central controller to allocate the segment. The segment used for the different purpose of the service can be as a source label or some this the VPN label, and other maybe the queues label like this way. And also the BGP can be used as the programming to download the programming result that from the controller to the ingress node. That means the source node. So that is means the programmed result can be downloaded through the BGP. Okay, next. Okay, and here this is the update of the Spring working group MPRS path programming. So this one is this draft is just to define the use case architecture and the protocol extension requirement. So here the updates is to enhance the requirement definition. So this one, the first is the requirement 5, that is introduce the specific endpoint to accept the prefix advertised by sender controller, because the central controller will send the route regarding the specific prefix. At the same time, it must to specify the receiver, so the receiver can use this the route from the central controller for the traffic steering for all the service for the service programming. And then the next one is the next requirement is the central controller send the route. At the same time, it should specify the priority for the prefix, because for a receiver, maybe it can receive the same route from the different source, but the priority is be identified by the central controller. It can be guaranteed the programmed the route can be selected for the prefix instead of other route. Okay, then the last one is the requirement 7. That means the means that is should change the some of the route selection rules in the client node, because the client node, because it has received multiple source for the same route, so it should give the higher priority to the route from the central controller, so that this is also to guarantee the programmed prefix to be selected with a higher priority. Okay, next one. Okay, so these updates are regarding to the MPRS programming in the IDR working group, because this is to define the BGP extension to support the service-oriented MPRS path programming. So the first 3 the BGP extensions have been proposed in the 0.0 draft. This means the extended label attribute because in this idea it need to download the label stack to the receiver, but in the existing the BGP label application is always only advertise one label specific to one prefix. So it must to use the extended label attribute to download a label stack for a specific prefix. And also because it map to the tunnel, so that it must to define the tunnel attribute. This include the unicast tunnel attribute and the multicast tunnel attribute. The attribute is to specify the tunnel ID for the tunnel to be used for the prefix. So to enhance the attribute BGP extension, the first one is a root flag extended community. Another is a destination node attribute. So I will introduce the details. Okay, next one. Okay, so this is the root flag extended community, because this is the extended community to define the root flag. So now the flag, if the flag is 0, means this treat the root as a normal root. If the flag is 1, so treat it as the best root. So the root is advertised by the central controller, so the flag can be set as 1. So when the receiver receives the root, so the root from the central controller can be selected as the best root, so that the programmed root can be adopted by the receiver. Okay, next one. Okay, this is the destination node attribute. So this attribute is to specify the receiver list. So this is the list is to specify all the receivers with their IP address. So this is the address list. So the receivers with the address in the address list, so it can receive the root, or else it just ignore the root. So this is to guarantee the right receiver to get the root from the central controller. Yeah, so this is the destination node attribute. Because this is a list, so we extended it as an attribute. Okay, next slide. Okay, so in order to verify this idea, so we do the prototype work. The prototype work is the inter-VPN steering. So the inter-VPN traffic steering, the solution is as this one. So the first one, okay. So this is the PCE initiated IRSP is created in the ingress node. So we use the BGP extension to change the tunnel for the VPN route in the ingress node. So we think this method can be, all the operations can be initiated from the controller. This is different with the traditional way, because the traditional way to change the to steering the traffic is always use a static configuration. So in fact, we also propose the tunnel selection the policy, the young model in the RTG working group. But in fact, we doubt in some scenario the performance of the netconf can not be satisfied. So we think the BGP does work. Okay, next one. Okay, so here this is just the demo. So we can see that at the beginning the VPN route use tunnel 1. The controller has all the IGP, the link states, and the TE attribute, and it also has all the VPN route. But later we see that we need to optimize the traffic for the VPN route. So we can use the controller, use the PCE initiated IRSP to set up a new tunnel. The new tunnel to change the next hop to the PE2. So after that, we send the BGP route from the central controller again to the ingress node, the PE3. So here, this includes this information. The first is the tunnel ID, is the tunnel 2 instead of the tunnel 1. Then it will use the root flag. This is the value is set 1. So it can make this route as the best route in the receiver. So then this is the third one is the destination node attribute is to specify the receiver. That means the P3's address. So the P3 can receive this route from the controller, but other PEs will ignore the route. Okay, so after receive this one, because the new selection rules is take effect in the P3, so it will directly use the route from the central controller as the best route. So it change the path from the tunnel 1 to the tunnel 2. So this can be, this can implement the traffic steering to the better queues for the service. Okay, so the next hop is to take comments and the feedbacks and then revise our draft. Okay.
Yeah, and I'm sorry we don't have time for questions and comments because we're running short on time. So if you have questions and comments, please send them to the mailing list. Thank you.
Okay, thanks.
Hi, yeah, this draft is about using BGPLU for label distribution for the architecture we defined called hierarchical SDN. My co-authors Chandra, Fabio, and Yakov are also co-authors for the base draft of hierarchical SDN. So what we want is we defined the base architecture in the other draft, saying that we have, this is like for data center cloud, that you got tens of millions of endpoints, how to scale that. It's not, the partition is needed only when you really concern the scale, otherwise it may not be your concern. So we partition in hierarchy. We try to balance the level of hierarchy small and also the individual partition in each individual number of nodes in each partition small as possible. Okay, move on. So we have some terminology here. Sorry for the typo. We have, this one is dealing with the underlay. So we're saying underlay partition border node and border node group, and BGP route reflector peer group, and then we have the label mapping server. We call it label mapping server. In reality, we modified the route reflector function be able to performing in a way we're doing BGPLU, but it's not the very regular way, because in this way we sign the labels ourselves depending on the partition. And the label itself has a meaning. We're not randomly sending a label. In that case, the mapping server knows about those label assignment and be able to give that back to the nodes. And there's a lot of regular vanilla BGP route learning. And we introduce a new concept called peer community because the partition. So we want to know these guys are in the partition, in the same partition, and these border nodes are in the same group. The purpose for that is we want to minimize, the whole thing about this architecture is to minimize the flip sides. If you're doing ECMP, right, if you're using one label for each one, then you have a lot of entries. So we want to use just one label. So how do you know you're in the same group? How do you know you're in the same partition? This is why we introduced this concept. And then we have route resolver, a single or a collection of entities provide the label stack to say where do you go. Our endpoint is a server. Next page. So here is just to introduce this architecture, so you keep it in mind when we go through the slide. You know, we're talking about the hierarchy. For example, the UP0, the top partition, level 0, it can be your DCI, your WAN network. And then for the UP1, we partition them Imagine that can commonly be one large DC or a region. There are several DCs depending on your topology. Just imagine that's a large DC, right? You can reach to them. And the last level partition is getting into the cluster or possibly a row of racks. So the label will eventually need to reach to the server. We're not talking about overlay right now, just talking about the label for underlays. So the overlay will be encapsulated inside. So with this one, in our base draft, it explained 3 labels can take you all the way through from one DC to another DC. One label is to identify which DC you're going, go through all the way. That is programmed in the fib. When we say programmed, there are 2 ways. One is use SDN controller directly program that, and the other way we're talking is using BGP. Because in between today and the final goal, we have a lot of existing equipment, and we have BGP in the network. So that's the low-hanging fruit to be able to do this, to distribute it. So top label take you to the correct DC. The second label will take you to the correct cluster, row or so. The last one would get you to the server. Next page. So this is the same thing as the other one, except we made it simpler with a name. Just remember this chart, right? Which one we're talking about? UPBN 111. There's one thing we didn't. These are in one group. Today we're only talking about ECMP, not TCP. And in the future we'll talk about it. So today it's saying. You're not like yeah, that's one group. And the lower one also, they're in one group. That means you can ECMP. You have 8 fan out, 16 fan out whatsoever, right? So you treat them as one. Remember this chart. Then we go through the pages. Yeah, next one. IGP. If it's IGP, right? In the case, in the core, maybe it's IGP, and then we talk about eBGP. In the data center, we use a lot of eBGP. So with the IGP case, we have basically you have the sessions. This guy is LMRR, is that the route server, that where you have all the intelligence, or you have all your label assignment is there, and there's a IBGP session here. If you're using IBGP between the 111 and the 211, they're in the same partition, but the 211 it's also in another partition. Remember, we have this overlapping. There will be IBGP, and between them is a different IBGP instance. Okay, next slide. So we're talking about eBGP. Next slide. Okay, I think we should just shorten to the concept. And basically, this is a setup, right? Then if in the eBGP case, between 111 and the UPBN 111 and the 211, they talk eBGP. They have eBGP sessions. They can advertise routes. And between the 111 and its LMRR, they talk about IGP. So next page. So basically, step 1, you can originate the self route. Okay, here's my NLRI, here's my next hub, and I don't know the label, and the peer community. That is the one we introduced, the peer community, because you want to know who is with who in one group. So the LMRR may act as a vanilla BGPRR for the label unicast route. And next page. So the second step is saying that the UPBN 211, they originate a self route. And the UPBN 111 can learn that, and the next page. And then can pass that to the LMRR 11. Okay, let's go next page, because we're short of time. LMRR allocate and advertise the labels. Here is because he knows the label. Themselves, they don't know, because we're doing kind of a central control. We allocate all the label. Basically, our label is allocated based on our location, where your server are. And you your label can tell your pass, exact pass, and in this one, no. This one is ECMP. If you particularly doing PE, you have your pass and destination all set. And the next page. So the last one is saying how, after you get MLRR, give you the label. Once that happened, and now before you send over the TIP, the tip, without label allocation, now you got a label. Once you got a label, you install in the FIP. And one thing it's worth mentioning, the whole design, right? It's not about BGP part, it's the whole design part where actually can squeeze the FIP sites among all the possible switches in the DC and in the network, in the core network, as if you do 4 million endpoints, it's 1.3K. So it's very, very small FIP set. That's our purpose to start this whole thing. And we want to use BGP because BGP is existing protocol. Everybody can support it, and we use it in our network. And we want to minimize the change of a protocol as much as possible. If we don't need to create something else, we don't. If we need this community, the peer community, people can suggest us which one existing. It will be good for you to use. Otherwise, we can create a new one. But in general, we want to use BGP able to distribute the labels. I think I ran out of my time for the rest.
Yeah, you did. Do you want a summing up slide, or that was enough?
Yeah, maybe just sum up.
You want that one?
Oh, the summary is gone. There's a summary page. Yeah, summary. Basically, we can learn the routes through regular BGP, and we place these routes as a vanilla IP destination, and then we send those to the LMRR for resolution of the label. And once the LMRR sends back, and here is your label, right? So we modify the BGP-LU usage. We depend on, I don't know my own label. You tell me my label, you tell me his label. And once those labels come back, then you install the FIP. Next step, because it's the initial draft, we like to hear feedbacks, comments, input, and we're going to finish in the next part on T next time.
Yep. And comments on the list, please. No time for at the mic. Sorry.
Thank you. And some things like Piers Yakov probably picked up from his past work that were successful. Yep. So I encourage discussion of this on the list. It looks like a beginning of an interesting bit of work.
Hello, everyone. This talk about BGP extension for beer. Next slide, please. According to the beer use case, beer could be used in multi-tenant data center networks to efficiently deliver broadcast, unicast, and multicast traffic. In some large multi-tenant data center networks, BGP instead of IGP is used as an underlay routing protocol. So this document describes BGP extension to advertise BIER specific information. Most specifically, a new optional transitive path attribute is used to advertise BIER specific information. Next slide, please. Okay. The BIER path attribute consists of one or more BIER TLVs. Each TLV is associated with a particular tuple of subdomain and bitstream length. MPS BIER encapsulation sub-TLV is a sub-TLV of the above BIER TLV, which encode the MPS BIER specific information, such as label based on label range size. Next slide, please. Implementation that support the bear attribute must support a policy to enable or disable the creation of the bear attribute and the attachment to BGP updates. Implementation may disable the creation of the bear attributes. A BGP speaker must only attach locally created bear attribute to a BGP update message in which one or more routable addresses is contained in the IRI. A routable address contained in IRI are actually the BGP next hop addresses. Next slide, please. Implementation that support the bear attribute must support per EPP session policy that indicate whether or not attribute is enabled on that session. The BIR attribute must not be sent on any EP session for which the session policy is not configured. If a BIR attribute is received on a BGP session on which the policy is not configured, the received attribute must be treated as if it were an unrecognized non-transitive attribute. To prevent the bear attribute from leaking from the BIR domain, each BGP router on the bear domain must support an outbound route announcement policy. Such policy must be disabled by default. Next slide, please. Assume that the bear domain is aligned with the administrative domain, which may consist of one or more ASs. Since the bear attribute is an optional transitive attribute, a non-BFR BGP speaker could still advertise received route with bear attribute. This is desirable in the incremental deployment scenario where a BGP speaker could tunnel bear packet or the payload of a bear packet directly to BFER. If the BGP next hop toward that BFER is a non-BFR, a BGP speaker is allowed to tunnel a bear packet toward the BGP next hop if these two BGP neighbors are not directly connected. For example, multi-hop EBP session. Next slide. That's all. Any comment? No?
If there are no comments, we're concluded. Thank you.
Okay.
Somebody please bring the blue sheets to the front, and if you haven't signed them, I implore you, please do.
How are you, sir?
And everybody, there is another working group in 10 minutes, so let's please move it out.
If you're not here for AVTX, please continue your conversations in the hallway so we can have... No, if you're here for AVTX, stay. If you're not here for AVTX, please continue your conversations in the hallway or your next meeting or wherever you want to go, but not here. Yes, thanks. If you are here for AVTX, please volunteer to be JavaScribe. I could be I don't want to be JavaScribe and chair at the same time, especially since I'm presenting. Yeah. Yeah. What? Well, we're kind of short of time on time, so I don't want to waste any time. Let's see about. Oh, yes, it is. Yeah, no, indeed. Matrix a little low. I'm not positive I'm actually powered. Does it have a switch on it? That'll do it. Yeah, there we go. Yes. Yeah, high power. Yes. Yeah, now it's on. No.
If you're here for AVTX, please find a seat. If you're not here for AVTX, please get yourself the other side of the door. Right, fun.